Hi friends, in the previous video we discussed about the signals and systems. I gave you a basic introduction to signals and systems. Now in this session we'll learn some more about signals. It means we'll learn about the classification of signals. Basically the signals are classified into two main types. Signals are classified into two main types based on their nature and characteristics of time domain. Signals are classified into two types based on nature and characteristics in time domain. What are the two main types of signals based on nature and characteristics in time domain? They are continuous time signal and the other one is discrete time signal. The first one is continuous time signal and the second one is discrete time signal. Here the signal is classified into two main types based on nature and characteristics in time domain. First let us learn about continuous time signal. In continuous time signal, the signal changes continuously with respect to an independent variable. As the name itself indicates, the continuous time signal changes continuously with respect to an independent variable. This continuous time signal take on real or complex values as a function of an independent variable which ranges over only real numbers. The main point is in continuous time signal, the independent variable values ranges on real numbers. Whereas in discrete time signal they range over integers. So in continuous time signal the independent variable values ranges over real numbers and it is denoted by x of t. Whereas coming to discrete time signal, here the signal information is taken only at some particular samples of time. In discrete time signal, the signal information is taken at only particular samples of time, whereas in discrete time signal it takes on real or complex values as a function of an independent variable that ranges over integers. Whereas in continuous time signal it ranges over real numbers, but in discrete time signal it ranges over integers. The discrete time signal is denoted by x of n. There are two main points in this classification of signal. The first one is in continuous time signal the independent variable values ranges over real numbers, whereas in discrete time signal the independent variable values ranges over integers. The continuous time signal is denoted by x of t, whereas the discrete time signal is denoted by x of n. I will make you understand clearly by showing you a diagram of continuous time signal and discrete time signal. In continuous time signal, we need to take t on x-axis and x of t on y-axis. If we consider the two figures A and B, in figure A, the signal is changing continuously with respect to an independent variable time. So the figure A is continuous time signal. Whereas in figure B, the signal information is taken only at some particular samples of time. So it is called as discrete time signal. It means here the information is calculated only at some time intervals, not at all the time. For example, the information is taken at -2 and again at -1, again at 0. In the same way it is happening all the time. So it is called as discrete time signal. This discrete time signal can be represented in 4 ways. Representation of discrete time signal. The first one is graphical. The second one is functional. The third one is sequence. And the fourth type of representation is tabular. In 4 ways we can represent a discrete time signal. The first way is graphical representation, the second way is functional representation, the third way is sequence representation, and the fourth way is tabular representation. Before going to explain you about these types, first of all let us take a question. Let us consider a signal. Let us consider a signal x of n. Since it is a discrete time signal, it should be represented with x of n. Consider a signal x of n with values. Let us take some values. X of -2 is equals to -3. X of -1 is equals to 2. X of 0 is equals to 0. X of 1 equals to 3. X of 2 is equals to 1. And x of 3 is equals to 2. Here the question has given like this. Consider a signal x of n with values. X of -2 is equals to -3. X of -1 equals to 2. X of 0 equals to 0. X of 1 equals to 3, x of 2 equals to 1, and x of 3 equals to 2. This question can be represented in these 4 ways. First let us try in graphical way. The value inside the braces indicates the value of n. For example, in x of -2 is equals to -3, the value of n is -2. So let us first draw the x-axis. If you consider the question, at x is equals to -2, the value is -3. What is the meaning of x of -2 is equals to -3? At x is equals to -2, its value is -3. So at -2 it is -3. At -1 it is 2. X of 0 is equals to 0, 0. X of 1 is equals to 3. At 1 it is 3. X of 2 is equals to 1. At 2 its value is 1. X of 3 is equals to 2. At 3 its value is 2. This is the graphical representation of a discrete time signal. Next let's go to the functional representation of a discrete time signal. Now let us learn the functional functional representation of a discrete time signal. First, let us write x of n values. X of n is equals to minus 3 for n is equals to minus 2. Next, x of minus 1 equals to 2 is given. What can we write from this? X of n is equals to 2 for n equals to minus 1. Next one, x of n is equals to 0 for n equals to 0. X of n is equals to 3 for n equals to 1. X of n is equals to 1 for n equals to 2. X of n is equals to 2 for n is equal to 3. This is about the functional representation. We can represent in this way a discrete time signal in functional representation. First of all, we need to write the values, and then we need to write the samples in functional representation. This is about the graphical and functional representation of a discrete time signal. Next, let's go to the sequence representation and tabular representation. Coming to the sequence representation, first we need to write the values minus 3, 2, 0, 3, 1, 2. These are the values that a sample holds in the given question. These are the x of n values for different samples. Now we are indicating a 0. At 0 we are indicating an arrow. What does this arrow indicates? This arrow indicates the 0th sample of a signal. Arrow indicates, this is the most important point, this arrow indicates 0th sample. It means at 0 its value is 0. Now it is minus 1. At minus 1 its value is 2. At minus 2 its value is minus 3. At 1 its value is 3, and at 2 its value is 1, and at 3 its value is 2. So the arrow mark indicates 0th sample of a signal. If arrow mark is not given in a question, in a sequence representation, if an arrow mark is not given, then we need to imagine that the first sample is the first value is the 0th sample of the signal. For example, let us consider one more sequence. X of n is equals to minus 3, 0, 2, 1, 5. Here arrow mark is not given, so we have to consider that minus 3 is the 0th sample. Then what can we say from this? At 0 its value is minus 3, and at 1 its value is 0, and at 2 its value is 2, and so on. This is about sequence representation. Next one is tabular representation. Next type of representation of discrete time signal is tabular representation. It is very easy, just we need to write the information given to us in a tabular form. N, x of n. What are the values that we are having from the question? The value of n we have, and the value of x of n we have. First we will write those values minus 2, minus 1, 0, 1, 2, 3. What are the x of n values of the given samples? At minus 2, the x of n value is minus 3 in the previous question. At minus 1, the x of n value is 2. At 0, the x of n value is 0. At 1, the x of n value is 3. And at 2 the x of n value is 1, and at 3 the x of n value is 2. This is about the tabular representation. This is the very easy topic. First, discrete. Once again I will revise the topic. What is continuous time signal? Generally signals are mainly classified into two types based on their nature and characteristics in time domain. They are continuous time signal and discrete time signal. What is continuous time signal? Continuous time signal is nothing but a signal which varies continuously with respect to an independent variable. The meaning of the continuous time signal is known to us very easily if we understand the word continuous time signal. The word itself indicates that it is changing continuously with respect to an independent variable. Here the independent variable may be anything like time. Next one is discrete time signal. Discrete time signal is nothing but in discrete time signal, the signal information is taken only at some particular samples of time. Not all over the signal. We are taking the signal information only at some particular samples of time. In discrete time signal, the independent variable values ranges over integers in discrete time signal, whereas in continuous time signal the independent variable values ranges over real numbers. The continuous time signal, it is denoted by x of t, and the discrete time signal is denoted by x of n. Again, this discrete time signal can be represented in 4 ways. The first one is graphical, and the next one is functional, and the third one is sequence, and the fourth one is tabular representation. One important point we have to remember, that is in sequence representation the arrow mark indicates the 0th sample. If an arrow mark is not given in a sequence or else in a signal, we need to consider that the first sample is the 0th sample of the signal. So this is about classification of signals and graphical and tabular, sequence, functional representation of discrete time signal. In the next video, we will learn about broader classification of continuous time signal and discrete time signal. Thank you for watching the video.